Alright, so today we're going to look over the Cambridge IGCSE International Examination, and we're going to have a look at the majoring exam from 2018, paper 1 for physics. There we go. So that's it. Physics, paper 1, which is the multiple choice question. There we go, and that's from May, June 2018. Alright, so let's start having a little bit of a look through that. And what we'll do, we'll quickly go through it and answer all the questions and show you how to work it out. Let's begin. There we go, question 1. The length of cotton is measured between 2 points on a ruler. When the length of cotton is wound closely around a pen, it goes round 6 times. So first of all, let's find the length of the cotton. We can see here that it goes between 2.4 centimetres and up at the other end about 15.6 centimetres. Which means the length of the string is 15.6 minus 2.4 centimetres, which gives us 13.2 centimetres. It's wound round the pen 6 times, so if we take 13.2 centimetres divided by 6, we'll find out how long it is to go round the pen once, and that will give us 2.2 centimetres. There we are. Option A. Excellent. Let's have a look at question number 2. A car is moving along a straight, level road with a constant acceleration. Alright, well, constant acceleration, here we go. Acceleration is given by change in speed over change in time. So we are looking for a graph that's going to relate speed and time. The distance and time graphs, both of them are straight lines, so neither of them are going to work for acceleration. We can ignore them, so it's not A, it's not B. Let's have a look down at C and D. There we go. Alright, so we've got a constant acceleration, which means, as acceleration is change in speed over change in time, we're looking for one where the speed is changing, and because acceleration is constant, it should be a nice straight line, which gives us option D. Just to show you where that comes from, A, the acceleration is change in speed divided by change in time. Well, if I do a speed time graph, then all it means when we do change in speed divided by change in time is that how much it goes up in speed divided by how far it goes along in time. Now, part and parcel for this type of exam, they tend to use the terms for speed and velocity a little bit loosely, because acceleration obviously is very specifically change in velocity divided by change in time. But this is the option we're going to use here. Okay. Question number 3. A car takes 15 minutes to travel along a road that is 20 kilometers long. What is the average speed of the car? Right. So what do we know? Well, we know that speed is given by distance over time. Now if you look here, all of the times given are in hours. And we've been given 15 minutes. Well, 15 minutes divided by 60 minutes in an hour will give us 1/4 of an hour. So that's how long it is. So our distance divided by time, we have 20 kilometers divided by 1/4 of an hour, or you could do 0.25, it's absolutely fine, which will give you 80 kilometers per hour. Option C. Let's go to question number 4. Diagram 1 shows a beam balance and a beaker with a loop balances the standard masses. The beaker is then removed and hung from a spring. The spring extends by 5 centimeters, as in diagram 2. The experiment is repeated with the same apparatus on the moon. Because why not? It's a Tuesday. Why wouldn't you go to the moon and do the experiment? Where the acceleration of freefall is less than on Earth. Alright, let's have a little bit of a look at this. In diagram 1, what we have is a balance of 2 moments, which means that force times distance 1, force 1 times distance 1 is equal to force 2 times distance 2. And of course the force on each side comes from weight. So that's mass 1 times gravity times distance 1 equals mass 2 times gravity times distance 2. And in diagram 2, what we have is the weight, mg, being balanced by the pullback from the spring. So what we have are two equations, F equals kx and rho equals mg. And we get a situation where kx equals mg. That's why it's balanced. Alright, so what's happening here? Well, we know it's being taken to the moon, which means the value for g is going to get smaller. If the value for g is getting smaller, here we go, this is getting smaller, then in order to balance it, the extension over here is going to get smaller. And on the left hand side, if the gravity gets smaller on one side, it also gets smaller on the other side. So we'll find that in diagram 1, everything's going to balance on the moon as it did before. And in diagram 2, the extension of the spring is going to be smaller. So let's see if any of the options correspond to that. Okay, so which statement describes what happens on the moon? The beam is balanced and the spring extends by 5 centimeters. No. The original extension was 5 centimeters, we know it's going to be less. The beam balance is balanced and the spring extends by less than 5 centimeters. Well, that's good. The right hand balance is higher, nope. And the right hand balance is higher, nope. So it has to be option B. There we go. Question number 5. An empty beaker is placed on a top pan balance. Some water is now poured into the beaker. What is the weight of the water? Ooh, see that? There we go, a little trick in there. They're asking for weight and giving you two values for mass. Alright, so what do we know? Well, let's find out what the mass of the water is. 0.106 kilograms minus 0.062 kilograms. Which is going to give us a value of 0.044. Okay, so this is the mass of the water. We want to find the weight of the water, and weight equals mass times gravity. Gravity in these exams is given to us to be 10. So the weight is given by 0.044 kilograms multiplied by 10 meters per second squared, which gives us 0.44 newtons. Option D. Question number 6. 3 liquids P, Q and R have different densities and do not mix. The liquids are placed in a measuring cylinder and are allowed to settle. A small block is then dropped into the measuring cylinder and comes to rest as shown. And it's going to ask us about the density of the block. Okay, so let's just do a quick comparison here. If the block sinks through the liquids, then it must have a higher density. So the density of the block is bigger than the density of R. The density of the block is also bigger than the density of Q, and the density at P is bigger than the density of the block. So let's see what statements are there that correspond to that. Okay, so statement 1 is equal to the density of Q. No, because it sank through it. It is greater than the density of P. No, because it's floating on top of it. It is greater than the density at R. Well, that's true. It is less than the density of Q. No, because it sank through it again. Okay, so that gives us option C. Let's look at question number 7. The diagram shows some liquid in a measuring cylinder. The mass of the liquid is 16 grams. What is the density of the liquid? Well, density equals mass over volume. We're given all the information we need. The mass is 16 grams. And the volume is 20 centimeters cubed. We read that, of course, from here. And that will give us a value of 0.80 grams per centimeter cubed, which is option A. Let's have a look at question number 8. A car is moving in a straight line on a level road. Its engine provides a forward force on the car, and a second force of equal size acts on the car due to resistive forces. Which statement describes what happens? Okay, so the car is moving along, and the force from the engine is equal to the force due to resistance. So nothing's going to happen. It's going to keep moving with constant velocity. There's no resultant force, so there's no acceleration. Let's look at this. Option A, the car changes direction. No, because there's no resultant force to make it. The car moves at a constant speed, possibly. In fact, again, it's an example of the examination board playing a little bit loose with the terms speed and velocity, but constant speed is a possibility. The car slows down. Nope, that's stupid. The car speeds up. Also stupid. Why? Because there's no resultant force. No resultant force because this force and this force are balanced. And here is our picture of a car. Beautiful car. There we are. It's going to move with a constant speed or constant velocity. The option is B. It's the only one that actually works there. 9. A hole is drilled in a square tile. The diagram shows the tile hanging freely on a nail. Where is the centre of mass of the tile? Alright, so it's hanging from a nail, so we'd expect it to be underneath that, somewhere in the line of action. Possibly D, possibly B. Now, from anything of this shape, we'd expect the centre of mass to be roughly in the centre. If I take a circle, I'd expect the centre of mass to be about there. If I take a crescent shape, in this case like a letter C, there we go, I'd expect the centre of mass to be about here. So in this case, I'm going to use the line of action to tell me it's either D or B, and then just the fact that I expect it to be in the middle to tell me it should be D. Question 10. The diagram shows the energy transferred in a lamp in 1 second. And which type of wasted energy is produced by the lamp? So we've got energy in, light energy out, and mysterious wasted energy. Well, what happens when we have a lamp? Let's take our basic lamp. Here we go. It's not a pretty lamp. It's a basic lamp. What do we have? Well, filament gets hot and it gives out light. Even now we're moved away from filament light bulbs, still the same effect. The gas in the lamp gets hot and it gives out light. Alright, so what type of energy is wasted? Well, the heat energy. Because we don't want heat, we just want light. So there we go. Straight away you can jump to the answer. It's not chemical potential energy. We're not making chemicals. It's not electrical energy. Electrical energy is what's going into it. We're being asked by the wasted energy produced by the lamp. Yeah. Okay, and it's not gravitational potential energy because the lamp isn't moving up and down. Why would it? Alright, so the answer is D, thermal energy. Question number 11. Which energy resource is not renewable? Well, fossil fuels are not renewable. Sunlight, we get plenty of sunlight. Tides come from the moon, and wind comes about because of sunlight. So all the others are renewable. Fossil fuel, not so much. So the answer is A. Question 12. A student does work by pulling a box across a horizontal floor. She now pulls a second box along the same floor. Which row indicates that the student is now doing twice as much work? Okay, well let's look at it. Work done equals force times distance moved in the direction of the force. So let's see what happens. If I'm using twice the force, then I'm doubling the distance, then I'm going to get 4 times the work done. Yeah, I only want to do twice the amount of work done, so it's not that. If I do twice the force and 1/2 the distance, then I'm going to get the same value of the work done. If I do 1 value for the force, so it stays the same, and double the distance, I'm going to get 2 times the work done, so that's a possible one. And finally, if it stays the same and I half the distance, I'm going to get 1/2 of the work done. So the only possible answer there is option C. 13. 4 identical beakers are filled with equal volumes of liquids, P or Q, as shown. Liquid P is more dense than liquid Q. And at which point is the pressure the least? Well, pressure in a liquid is given by density times gravity times height. So what we want is the smallest density and the smallest height from the top. Okay, so it's either going to be B or it's going to be D. Which one has the smallest density? Let's see. P or Q is shown. Liquid P is more dense than liquid Q. So I want liquid Q, which is then D. There we are. 14. A woman with a weight of 600 newtons. She stands on a horizontal floor. The area of her feet in contact with the floor is 0.05 meters squared. What is the pressure she exerts on the floor? Well, nice and easy. Pressure equals force over area, which in this case is 600 newtons divided by 0.05 meters squared, which will give us a value of about 12,000 pascals. And that is, of course, standard form, 1.2 times 10,000 newtons, which is just 1.2 times 10 to the 4 newtons per meter squared. There we are. Option C. Now let's go to question number 15. On a warm day, a carton of fresh milk is covered with a wet cloth. Why does this help to reduce the temperature of the milk? Okay, well, it's a wet cloth, so what's going to be happening is the molecules of water with extra energy are going to evaporate and take that extra energy with them, and the remaining water will be a little bit colder. Okay, so there we go. Option A, some water evaporates from the cloth, so the remaining water becomes cooler. That's it. Water has a high thermal capacity. You know, it doesn't matter what the water has at this point. It's irrelevant to the question. The water could have a cup of tea. It doesn't matter. The water insulates the milk from the warm air around it. Not entirely untrue, but it's not talking about reducing the temperature of the milk. It's a no. It's not untrue, but the more true answer is the fact that some water is evaporating and the remaining water becomes colder, so it produces a cooling effect. And also there's no guarantee that the warm air around it is warmer than the milk. It says the milk is fresh, not cold. And water is always colder than the air about it. That's a terrible answer. Okay, so the answer is A. 16. Air is trapped inside a cylinder by a piston. The piston is pushed inward and the volume of air is reduced. So volume is reduced and it's pushed inside. The temperature remains constant. Oh, that's nice. Which row describes the average speed of the air molecules and the average distance between them and how it changes? Okay, well, temperature is proportional to the average velocity or the average speed of the molecules. Okay, so if the speed remains constant, if the temperature remains constant, then speed is also constant. So a couple of possibilities then, it becomes C or D. Now, we're pushing all the air in the piston together, so the average distance between the molecules, it's going to decrease. Option C. 17. A wooden wheel can be strengthened by putting a tight circle of iron around it. What action would make it easier to fit the circle over the wood? Well, if you take this iron circle and you heat it up, it'll get bigger. Okay, so if you cool the iron circle, it gets colder. That would make it a real pain. No, heating the iron circle, that's a possibility. Heating the wooden wheel and cooling the iron circle, well, that would really annoy you if you tried to do that. Heating the wooden wheel but not heating or cooling the iron circle. No. Foolish, do not do that. You want option B, heat that iron circle. 18. A student wishes to calibrate a mercury and glass thermometer with a degrees Celsius scale. Good for them. Which value should she use for the lower fixed point and the upper fixed point? Well, it's degrees Celsius scale. So it's going to be ice, which is just melting, and that's 0 degrees Celsius for the lower point, and water, which is boiling, pure water, which is boiling, and that's 100 degrees Celsius. All right, so the lower fixed point should be the melting point of ice. There's a possibility of melting point of mercury? I think not. Upper fixed point should be the boiling point of water. There we go. That's the one we want. Option B. 19. Which row gives the correct name for each change of state shown? When something turns from a gas to a liquid, it's condensing. So it's not evaporating. Let's score out C and D. When it changes from a liquid to a solid, we've got solidification happening. And just double check, going for the third one. When it changes from solid to liquid, it is indeed melting. It is option B that we want there. Question 20. On a cold day, a metal front door knob X and a similar plastic knob Y are at the same temperature. Why does X feel cooler to the touch than Y? Well, because it's really good at conducting the heat away from your hand. So let's look at the answers. X convects thermal energy better than Y. No, convection is all about gases moving around because of changes in density. B. X is a better thermal conductor than Y. Yep, it's possible. C. X is a better insulator than Y. No, it's not. It's why your hand feels cold. And D. X is a better radiator of thermal energy than Y. Well, that would depend on the colour of it. And, it may well be a better one because it's metal, but, no, the reason it specifically feels colder is because it's thermal conducting. It's not radiating heat away from your hand. So let's go with B here. 21. A liquid is heated and it expands. How does this lead to the formation of convection current? Well, the density of the heated liquid decreases. There we go, that's absolutely true. The density of the heated liquid increases? Nope. The mass of the heated liquid molecules decrease? No, same number of molecules, nothing happens to the mass. The mass of the heated liquid molecules increases. And no again. So it's option A, the density of the heated liquid decreases. And that's why things move around to set up large convection currents. Question 22. Which arrow on the graph shows the amplitude of the wave? Well, nice straightforward one, straight from the diagrams in the book. Option B. Option D is a wavelength, but that's not what we're after at this point. This is purely just asking us to find the amplitude, which is option B. Option A would be twice the amplitude, and option C is 1/2 of the wavelength. 23. In which situation is the wavelength of the wave changed? Light from the sun passing from air into water? Well, yeah, that would do it. Because C equals F. Lambda, the frequency never changes, and the speed of light in water is slower than the speed of light in air because of the refractive index. Let's look at the other options. B, radio waves travelling from an Earth satellite to the moon. Nope, no reason for them to change. They're in space regardless. C, sound reflecting from a wall. Doesn't change where it is. It's reflecting, not the stuff being transmitted. And D, water waves passing through a narrow gap. No, and no there as well. Alright. 24. Scout P signals to Scout Q on the other side of a valley using the mirror to reflect the sun's light. Which mirror position allows the sun's light to be reflected to Scout Q? Okay, well, if we look over here, we can see we want it to come down in this direction. So let's see which mirror will give us that option. Sun comes in, hits this mirror, bounces off down here. That's looking pretty good. For B, it's going to bounce back pretty much the way it came from. C, it's going to bounce over in that direction, no use at all. And D is going to bounce straight down into the ground. So we're going to want option A to bounce it back in the right direction. There we go. Question 25. The diagram shows the electromagnetic spectrum. The numbers indicate the approximate wavelength at the boundaries between the various regions of the spectrum. For a device to be able to make use of the electromagnetic spectrum, it needs an areal of approximately the same size as the radiation it's designed to work with. Alright, which statement is correct? Well, a mobile phone uses radiation from region P. That would mean your mobile phone would have to have a little bit sticking out of it that's about a metre or larger. That would be quite awkward to hold in your trousers. B. A television satellite dish uses radiation from region Q. Yeah, satellite dishes are, about 60 centimetres across. I'll go with that, that's possible. C. The receptor cells in an eye use radiation from region R. Ooh, tricky. No, the visible light spectrum is really around about here from blue all the way up to red. Slightly ambiguous there, but I'm going to say no. Visible light's in S. And D. The remote controller for a television uses radiation from region U. That's some pretty high energy radiation. you wouldn't want to be using that in your remote control. No, it's infrared for these tender remote controls, so that would actually be over about here. All right. So let's go down to the next question. Oh, mark it in. The answer was B. 26. A dolphin has a range of audible frequencies of 150 Hz to 150 kHz. Which range of frequencies can be heard by both humans with good hearing and by dolphins? Well, humans will hear from 20 Hz to 20 kHz. So we want to know where they both overlap. Well, that's from 150 Hz all the way up to 20 kHz, which is option D. Let's come to question 27. A permanent magnet is placed close to a bar of soft iron. What are the polarities of end P and end Q? Alright, basically the soft iron on the right hand side is going to become magnetized, and it's asking which side is north and which side is south. Okay, so in order for it to be attracted, as it would be, this is going to be a south, this is going to be a north, so P should be S, P should be south, and Q, end Q, should be a north. There we go. That's it. C. Question number 28. Which metal is used for the core of an electromagnet? Well, the answer to that's one that you need to know straight off the bat. It's iron. An iron is a softly magnetic, which means it loses its magnetism easily, which is why it's so good in an electromagnet. 29. The diagram shows a cell connected to 3 resistors, R1, R2 and R3. A student connects an ammeter first in position 1, then in position 2, 3 and 4. In which position does the ammeter show the current in R1? Alright, so R1 is here, that's R1 here. It's in this section where all the electricity is travelling through. So you're going to get the same reading from R1 from the ammeter as you will in position 1 and in position 2. When you get to position 3, the electricity, the current can go in either of 2 directions, as this way, or it could go this way. So it's being split. The only other place where the current's forced back together along the one wire, position 4. So 1, 2 and 4 will all give you that same reading. So there we are, answer A, 1, 2 and 4. A plastic rod is rubbed with a cloth. The rod becomes positively charged. What happens to the plastic rod and what is the charge on the cloth? Okay, so we start off with a plastic rod, which is neither positive nor negative. It has some positive charges, has some negative charges, like so. It is rubbed by a cloth, which has similar number of positive and negative charges within it, so it's both neutral. So when they rub together, what's going to happen, of course, is that some of the electrons are transferred. The rod becomes positively charged, so it's going to lose some electrons to the rod, to the cloth. So the rod is going to lose electrons and become positive. The cloth is going to gain electrons and become negative. So plastic rod loses electrons and the charge on cloth becomes negative. There we go. Option C. 31. A student measures the potential difference across a device and the current in the device. Which calculation gives the resistance of the device? Well, we know V equals IR. In fact, nice and easily, of course, we can put it into our equation triangle. There we are. We want to find the resistance, so we just cover over the resistance, like so. We find that R equals V over I. So resistance is given by the potential difference divided by the current. Option C. Question 32. The diagram shows 3 identical resistors, 3 ammeters and a battery connected in a circuit. What is the order of magnitudes of the readings on the ammeters from smallest to largest? Ooh, alright, so it's 3 identical resistors, that's important. Now, ammeter 1 is going to have the largest reading because all of the current has to travel through it. So, ammeter 1, I1, is going to read bigger than, see, both I2 and I3, but the next one up is going to be I2, because there's less resistance there than there is on I3, on ammeter 3, sorry. So I1, I2, and I3. So smallest to largest. Oh, so the one on the left-hand side will be ammeter 3, and then ammeter 2, then ammeter 1. That leaves us option D. 33. A student sets up this circuit. What do we have? A thermistor, which obviously changes its resistance as it gets warmer. The resistance decreases. And a bell. That's what that shape is. What is the purpose of the circuit? A, to allow a lamp to be made dim. There is no lamp. No, it's not A. B, to amplify the sound of a voice. Using a bell? I think not. C, to light a lamp in the dark. A lamp in the dark of this question? No. D, to sound a bell when the temperature rises. I'm going to go with D. I like the sound of D. 34. The diagram shows two voltmeters P and Q connected to a potential divider. The sliding connection at point P is moved towards the top of the diagram. What happens to the reading on P and the reading on Q? Oh, interesting. Okay, so let's just draw out what's actually happening here. As we have a few different points in the center, what we're going to find is the voltage reading at P is going to be equal to the voltage reading at Q. As we get to the top, the voltage reading at P is going to be much smaller. The voltage reading at Q is going to be much larger. And at the bottom, the voltage reading at P is going to be large, and the voltage reading of Q is going to be small. Okay, so we're moving from the center upwards, so the voltage reading on P is going to decrease, so it's one of the top two, and the voltage reading on Q is going to increase, which gives us option B. It's the only possible one. 35. Which statement about electromagnetic induction is correct? Okay, electromagnetic induction is where you have a changing magnetic field and a conductor, and it creates a voltage in the conductor. So you need a changing magnetic field. Alright, so a strong magnet is held stationary near a stationary conductor. Well, that does nothing. B. The effect occurs when a magnet and conductor both move with the same speed and same direction, so they're not moving relative to each other at all. There is no changing magnetic field there. C. The effect occurs when a magnet is moved away from a nearby conductor. That will happen. And D. The effect only occurs when a magnet is moved towards a conductor. Ooh, not untrue, apart from this bit. It says only occurs. So that's wrong, because it also occurs when the magnet moves away from the conductor. Changing magnetic field and a conductor is all it needs. Question 36. An electrical device changes the voltage of an electrical supply from 240 volts AC to 20 volts AC. What is this device? Well, it's actually a transformer. There we go. And a transformer can change the voltage of alternating currents. It doesn't work with direct currents, but alternating currents, it works wonderfully. So, transformer. None of the others will do that. 37. In the atomic model, an atom consists of a central mass orbited by much smaller particles. Well, here we go, it's the nucleus, and that's made up of protons and neutrons. When I'm reading through these questions, I like to write down what I see. The reason is it just makes me more cognizant, more aware of what the question's asking. And round the outside, we have an electron. Let's see what it's going to ask us. What is the name of the central mass and of the orbiting particles? Well, nucleus and electron. So central mass, nucleus. Orbiting particles, electrons. See, central mass is not the neutron. Neutrons are part of it. The protons also make up part of the central mass there. 38. A neutral atom of argon-40, there we go, and a neutral atom of potassium-39 are compared. Which atom has more electrons and which atom has more protons? Alright, so the neutral. So what we know is the number of protons is the same as the number of electrons. So the question is, which one of these has more protons? Now, the proton number is a smaller number. It's the number at the bottom here. And if we look, we can see potassium-39 has 19 protons. There we are. Whereas argon only has 18. So the one with more protons is potassium. And the one with more electrons is also potassium. So it's option D. And 39. Which statement about alpha particles and beta particles is correct? Ooh, let's see. It's talking about ionizing and penetrating. So let's see that. Alpha particles, really ionizing. They're the most ionizing type of radiation. Ionizing. And beta particles, they're more penetrating. Not more penetrating than gamma radiation, of course, but that's not on here. Just alpha particles and beta particles. So I want to find the one that tells me, the option that tells me that alpha particles are more ionizing and beta particles are more penetrating. So let's see. Option A, alpha particles are less ionizing than beta particles. Rubbish. I laugh at that stupid answer. B, alpha particles are more penetrating than beta particles. Also not true. You can pretty much stop alpha particles with a bit of paper. There we go. Option C. Alpha particles have a greater mass than beta particles. Ooh, we're going on to mass. Interesting, because alpha particles do have more mass. So yeah, that's actually true. Alpha particles have a greater mass than beta particles. And D. Alpha particles have the same charge as beta particles. Not true. Alpha particles have 2 positive charges and beta particles 1 negative. So that's option D then. There we go. Let's look at question number 40. Last question. Here we go. An explosion in a nuclear reactor spread the isotope cesium-137 across a large area. That's fun. 90 years after the explosion, the quantity of cesium-137 present will be 12.5% of its original level. What is the half-life of cesium-137? Well, let's look at that. Okay, so just a little graph here. No, sorry, little graph, little table. Number of half-lives down there, and amount left. Okay, so no half-lives, we're going to get full amount left, 100%. 1 half-life, we are going to get 0.5 left. 2 half-lives, we're going to get 0.25. 3 half-lives, we're going to get 0.125, which is, of course, the same value we have here, 12.5%. So it's been 3 half-lives in a time of 90 years. So 3 half-lives is 90 years. So 1 half-life is 90 over 3 years, which is, of course, 30 years. There we are, 30 years. Option C. Job done. Well done, everybody. Okay, now I'm going to add a few more videos every now and then. I'm going to try and upload more of these question papers that I'm running through and more ideas for answering questions. If that interests you, then please feel free to hit the subscribe button. Otherwise, one way or another, have a great day.